Okay. Hello, good morning. I'm Alan. I'm from Eidolink Product Manager. So I'm going to introduce our SWORM atomic solution. So in a smart factory. Okay. So I will go through this to the top here. Okay. So this agenda here, I will go through like the atomic solution and this kind of the factory. Want to have the transfer, what the transfer face out. And with offering, and offering the feature, the advantage, blah, 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 and the benefit of the market. Okay. So this is the best one. In the past, our company is focused on the automatic. So we just focus on like the A motion control, B motion vision, IO sensing, AI, AOI. Lots of things is in the factory. So the machine is automatic. So in the past, we focus on this one, right? But nowadays, try to image that if the machine can talk each other. Okay. So we call the SWORM autonomy. Okay, SWORM autonomy for our concepts that we try to make the machine talk each other. So how can they do that? You can know in the factory, no matter old one or new one, the AMR is a physical machine can go through into the factory everywhere. So if the message can bring by themselves, so I can bring the message to one machine to another machine or maybe the third machine. Okay, so here I will say that we try to make our factory from automatic to autonomy. So the AMR is quite the physical things here we provide. And the AMR can communication with the machine or maybe OT level, IT level. So IT level is like ERP, OT level like all the machine in the factory. They can communicate by themselves. So you will reduce the labor. And also they will optimize production efficiency. Okay, with the autonomy mobile series. So this is a very simple concept about autonomy. So the next I will go to talk about the challenge. If like the factory want to transfer the automated autonomy, what kind of challenges we can face? So put it simply, there are two challenges we sum up. Okay, the first is the difficult in developing integration. Another one is the complicated operation process. Okay, so the first here we can see in the factory, no matter new one or the old one, legacy one. So there are lots of machines, right? And the machine, they will come with the multi-brand, and the multi-brand have their own systems. And I just mentioned that SWORM autonomy need to combine with the OT level and the IT level, so you can image that. So lots of the different brand, different system, so it's really hard to integrate or to combine with every system. Okay? And based on this one, the complete operating process like that. So the old systems, like we have the lots of AMR brand, right? So each brand, they have their own robot control systems. And the IT level, maybe we have a warehouse control systems, maybe ERP, lots of systems. And the systems is all nowadays, lots of factories all controlled by the operator or workers. So the machine, the information or the data is a synchronized communication beyond this. So these two things is kind of a challenge. We talk to the factory owner. They try to transfer their type from automated to autonomous. So the offering here, we offer two kind of product here. Okay, one is AMR, just I mentioned, is a physical things goes to factory everywhere. So we provide AMR, and we call SMR here. The S means the SWORM. Okay, so we try to name our AMR names called SMR. So another is SWORM core. AMR we provide two kinds of payload, 100 kilograms and 250 kilograms. It depends on a different scenario because you take out like maybe you have a robot conveyor or maybe you have the big rocker, small one. So different payload, you can use the different SMR. Okay. So another is the SWORM core. SWORM core is just a software. You can image just the operating systems. So SWORM code just a software. We just put the SWORM code into the server. So it's like edge controller, like PC, computer, server, everything, just a computer. And the SWORM code, what does SWORM code do? SWORM code try to make the user easier to configure the machine and operating and monitor. And the SWORM code, we have two kinds of feature here. One is going to combine the old machine. Another is we have our dispatching systems. Okay, next I will go to have two feature about these two products, and I'll try to use the feature to give more detail about the autonomy, what we can do. Okay, so SWORM code, one of the features is the heterogeneous integration. Okay, heterogeneous integration. So just as I mentioned, in the, this is a factory, right? So in the factory, OT side, we can see normally in the factory, we have the, our AMR here. And maybe the factory, the legacy one, they have their own third-party AMR. And maybe in the factory, we have the device, third-party device, like elevator, like PLC, like rack storage. So each device here. And also we have a third-party top modules. Just as I say, the AMR has a different function. So maybe one function is like combined with conveyor, maybe combined with a robot. So AMR will take a robot to go where they go to pick up or drop off the things, right? So it's the OT side. Normally we just separate it into this product line, okay? Then IT side, quite easy. Third-party IT systems like MES, ERP, depends on the factory owner what they have. Okay, maybe, ERP and MES is quite common things to see in a factory. Okay, so what the SWAN code doing? Okay, SWAN code, we provide the SWAN protocol. You can see SWAN protocol try to unify the communication. So SWAN protocol just like a highway, just a highway. So the highway is here in the factory. So we try to make each component to connect with the highway. So basically, our AMR we just already integrate inside. So already integrate in our SWAN core. So our AMR is quite no need to do anything, just connect to the SWAN protocol. And the SWAN protocol will deliver the message or data in time and synchronously. And how about IT systems? I mean, the IT system, we provide the SWAN core API. SWAN core API is kind of CK, which means that if the ERP system, no matter big or small one, you can modify by yourself. You can just directly use the API, so you don't need to do everything to do the transfer. So SWAN API will connect with the IT system to SWAN code. So basically, we can see that if the ERP system send a message from the IT system, send a mission to the SWAN code, and the SWAN code will dispatch in the AMR to do the things. So try to image that everything will go to the SWAN protocol and make the data and the image information synchronously. And how about third-party device? As you know, third-party device has their own protocol. Like maybe the robot have like either camel bus or maybe OPC and the Profinet, lots of protocol worldwide, right? So about this kind of the third-party top module, and also have the third-party IT systems. This third-party is like, because some IT systems are quite big, and you don't have the access to directly modify the core in the third-party IT system. So for this kind of third-party innovative IT system or OT system, we provide another tool, and we call SWAN Reaper. Okay, so SWAN Reaper is kind of the SDK. SDK try to connect the third-party through their protocol, and SDK just like we try to make it very easily. Okay, so I will introduce you later. Okay, so the SWAN code one feature is going to about the heterogeneous integration. So we provide the SWAN code wrapper and the SWAN API, and try to make the machine in the factory connect to our SWAN protocol, and try to make all the information or data, go through very in time and synchronized, have the communication here. So this is a SWAN code one benefit and one feature here. And by the way, so as you know, in the factory, we try to make the data connect together, right? So maybe we use the Wi-Fi, Wi-Fi internet to make each machine go to Wi-Fi side. And our AMR also provide a private 5G. Okay, private 5G is another trend of the factory. Okay, so our company is going to provide like a private 5G servers. So our AMR, definitely we will support the private 5G protocol here, right? Okay, so this is one of the SWAN code feature. Another is going to, I just mentioned our SWAN code have the dispatching system, which means like a fleet management. So the dispatch systems, we use the event-based control. Event-based like ERP will send the mission one, like mission one means like maybe, hey, AMR will go from machine A to machine B or machine B to machine C. So each machine will define to event-based. So we use this kind of event-based control management, and we have our dynamic reschedule capability. So I will give you like 3 scenarios on the right-hand side. Yeah, on the right-hand side, 2 scenarios to put it simply how it works. Okay. So the first one here, we can see there's a factory and there's a cargo here. So the ERP will send a message to our Swan code. So Swan code will very similarly to ask one of AMA to pick up. Okay, so that's very easy. Another scenario is that there's another cargo here. Another cargo here. So actually, yeah, it's the same. So our Swan code will get the command, get the mission from ERP, and another AMS comes. Okay, but if something happened on the road here, maybe some obstacle here happened, something is here, so it stopped the AMR the way to the cargo. We have the timeout. So you can set out timeout you can set out 5 seconds, 10 minutes, 30 minutes. So if you're counting down, and then maybe the operator cannot handle this kind of the situation, the AMR will go to another way. So we call our backup road. This AMR will go to another way to pick up the cargo to finish the mission. So we call it dynamic resource capability. Okay. So the third scenario is here. Just like if the situation stay here and the layer third AMR comes to want to go this way, but our Swan code will talk to the third one and talk to him, say, oh no, we cannot go this way. So they will pick up another way. So we call the traffic control. Okay? So these three scenarios going to describe our dispatching systems. So we try to make the material waiting time to make them no need to time to wait. Okay, so our Swan code will automatically to decide which AMR goes to pick up and which AMR to go to another way to avoid this kind of things. And just as I said, Swan code will have this kind of supervisor. So we try to make the labor, make the operator to have the last fleet supervisor. Okay, so this all the things is automatic run our Swan code. Okay, so these two features about Swan code, and I think these two features kind very simple to understand and try to image everything must go to the Swan autonomy, so make every equipment can talk to each other by this way. Okay, so I will say another advantage of our Swan code, because in the factory, I think we try to make the device or maybe use the UI or method one simple. It's quite good, right? So what our UI provide. The first thing is that our UI provides the agent info. You can see the middle one is our AMR, right? So this is real case in Taiwan. So we just integrate the third-party AMR here and the other third-party AMR here. So you can see from this UI, you can manage all the devices you have already integrated into the Swan core. Okay, so the top here, we can see there's a conveyor, elevator, top modules. It's kind of third-party device. It's not a robot. It's not a car, right? So this kind of third party, we use the Swan wrapper here. So you can see we have a wrapper A, just combined with the conveyor. Wrapper B, which is already connected with the PLC in elevator. So the Swan code can control the PLC, ask the elevator to open the door, and AMR goes through, and then go down, go up. Okay. Also top module as well. So this is J info. And right now our wrappers use the Python to modify, but in the Gene we will provide the UI. Only UI, so the user, the system integrator just use a click. They were easier to connect the supply device into Swan core. Okay. So the next one is real-time monitor. In this Swan core, the UI also provide a real-time monitor to check, okay, how is the situation, how is the things in factory here, so we can see where's the AMR and where's the AMR, what happened. So it's a real-time monitoring. And the third one is workflow operation. Just like I said, it's more complicated here. Because the AMR, we don't have a cycle, which means that Swan code will automatically decide which AMR will pick up the missions, right? So in the Swan code, we need to define the simplest workflow, like point A to point B, okay? So this, our code is one workflow. So we need to define the workflow operation in this UI. So it's very very simple. Like you just put out what the command you want to give the AMR. So the Swan code will know which AMR need to use a different workflow. Okay. And the last one is the state management. So in the factory, we will show how the AMR works now, and everything will have the data here, so user can easily to see what they want to see, the status management here. Okay, so we try to put everything into one software, our Swan code, and try to make user easier to connect, no matter the third party or the our solutions here. Okay, so this is all Swan code. The next is about the SMR, physical things. So this page is easy to understand. So about the physical things, SMR, we have our experiment. Our docking per moment right now is plus and minus 5 millimeters. So compared to tier 1, another brand company, I think it's nearly the same performance here. So it's you can use the SMR to maybe more critical environment here. Okay. So another is another is the dynamic parameter zone setup. This is related to the safety. Okay, the SMR goes to the factory about the safety. So I will go to explain two. One is here. You can see the circle line, the blue circle with the blue line. This is our SMR. Just imagine this SMR, our car. And the red one and the yellow one is a safety distance, which means that if the SMR goes through and something in front of it into the yellow area, they will slow down, and into the red one, they will stop. So it's quite understand. I think each area have this kind of function, right? But we have the two scenarios. Just as I mentioned, our ML can combine with the top module, right? So the scenario one is here. Here, this is a conveyor, right? The top module conveyor. I use conveyor to make as an example. So you can see conveyor is bigger than our AMR. So I just combine with the conveyor with our AMR, and we need to set up the step distance change. Okay, so the AMR knows like how safety distance far they need to know. So if we go to the factory, they need to know, oh, I can go this way. This is quite small. I need to go another way. Okay, so this is top module here. Try to make it's about safety, more safety. Another scenario 2 is about rock. I say SMR in factory. Okay, sorry. SMR in a factory has two different kinds of usage, right? So one is combined with the top module, another is combined with the rack. Rack means that rack is everywhere in the factory. So our SMR can lift on the rack, one of rack to another way and put down, and it goes to pick up another rack. So as you know, rack is have different size in a factory. So we can set our rack size in Swan code, and just as I mentioned, our AMR is automatically assigned by Swan code. So the AMR 1 maybe goes to rack 1, they will dynamically change the safety zone, okay, to make sure the safety zone is changed. And if you go to a small one like rack 2, they will be smaller. So this is the safety zone change depends on top module or rack, okay. So the next one is the mass speed setting in different area. This is the real case in Taiwan, right? So you can see the area 1, each machine is very not close. It's not close. And compared to area 2, the machine, the machine is a blue circle. So each machine is quite close, right? So we can set up the area 1 define like the small, which means that no matter which AMR goes into area 1, they will use the max speed like 1.5. But if we go to the area 2, we can set out like a bigger one. And so which AMR goes to here, they just use like 0.6, the limit. They will have the restriction of AMR speed. Try to make AMR more safety in the factory. Okay? So these two things are very permission our SEPA in our AMR, which means that we want to our AMR more safety in the factory. Okay. All right. So what our solutions benefit about Swan autonomy? So just I mentioned Swan code. Swan code is kind of a software, and we provide Swan wrapper SDK or maybe Swan API. Try to make a third-party device, no matter OT or IT side. Okay, easy integrate. Just use one method for better development. And the second is the highly flexibility. Just as I said, the environment in factory is more complicated, right? So no matter which the factory you face up, the ISM has their own safety setup for the dynamic change and also the swarm code dispatching systems to face out maybe something happening in the room. Okay, so these things I try to make IHOE. So which we believe that from automatic to autonomy, so we try to make the machine can talk each other. You can reduce the labor time. Okay. All right. So this is a case in our factory. I just want to say we built in 1 week for the demo because the swarm code is quite easy. So the simple as we combine with the robot and the AMR and then the machine. So we just put that simply just 1 week to finish this scenario. Okay. Okay, so normally I would say a target market, but I put three optoelectronic, SMT, semiconductor. I think this is a target market for autonomy. Right now we have three kind of the AMR with the top module, and it's a project ongoing. So you can see for no matter different industry, our AMR can combine with the different top modules. Depends on the system integrator's know-how. Okay. Okay, now to give the very simple competitive analysis. Okay, here there's a brand end and a brand edge. Okay, brand edge you can see AMR AGV. Okay, in the past they use the QR code, maybe the guideline in the floor, but our AMR uses system technological. So they no need to put everything on the floor. And the accuracy with the marker, I just mentioned that plus and minus 5 millimeter. And another thing is the classroom. Okay, because in the menu, I think, because we just got the class 1000 level in the last week. So this is the latest classroom level in our SMR. And I want to say that our MR have the private 5G. Okay, private 5G is another trend in the autonomy manufacturing manufacturing. So private support I think is most important as well. Okay. All right. So just sum up what we provide. I just say we provide two payload, 250,000 PPTs and 1,000 kilogram payload. And I will say with a lift, it's normally used with a rock. Without lift, normally with a robot or conveyor. Okay. I just recap what we are going to talk about the automatic to autonomy. So from automated machine is quite easy, everyone is doing that. But autonomy, we try to make our machine can talk each other to reduce the communication time, try to make information talk to each other in time and synchronously. So we provide the feature here, Swan robot and Swan code. Okay, and the Swan code I just say one UI, one method, try to make our user make easier to help them to transfer the type for automated autonomy. And no matter the Swan code, we have also have the docking performance, the parameter zone setup. We are not only provide the software, we need to provide the XML as well. Because combine these two, we will just like have a more powerful performance for this solution. Okay, so benefits like we try to have a high efficiency, high precision, efficiency integrate here. Okay, I'm Alan. So thank you very much. I give you very quick rough introduce about the SWAM autonomy solution, and we give you our solution here. Thank you very much.